So they have a lot of features in them, because of which the magnetic field lines, they do what is known as a reconnection. So because of this reconnection, there's a lot of heat generated, like, like that happens in your electrical circuits, for example, the I square R losses. So in layman's term, these are like I square R losses, and these also give rise to heat. So there is no consensus yet in the community now about which mechanism dominates in which part of the sun. So that is one of the grand challenge problems in solar physics. Of course, there are more, but right now I can think of two which can be explained in a simple manner.
Thank you, Piali. So I think we heard quite a bit from Piali and Vagish about the fact that the sun is still a study, object of study. We still do not understand everything about the sun, and therefore there are solar astronomers studying every aspect of the sun using ground-based telescopes and the upcoming space mission called Aditya, as well as simulations and theoretical studies and observations and so on. So it's still a very, very active field of study. And we hope that some of you here today will become solar astronomers because of today's eclipse. So there's one question I wanted to take. Before that, there are many more comments about eating and drinking during the eclipse. So we would like to repeat, yes, you can eat during the eclipse, you can drink during the eclipse. It's absolutely no harm caused. Yeah, it's basically a eclipse, basically a play of shadows. The moon is coming between us and the sun. It could well have been your hand, it could have been a building, it could have been anything else. It's no different from you hiding behind the shadow of a building during a hot afternoon, and therefore eclipses have no harmful effects on us at all. The sun and the moon doesn't really care much for our lives, really. And the only thing we have to worry about is do not look at the sun directly with your naked eyes or through a telescope or a pair of binoculars or anything at all. You will damage your eyes, so please do not do that. Okay. There was one question which said, how did our ancestors know how to predict eclipses? That's an excellent question. So eclipses have always been things which scared people, right? If you not know how an eclipse is caused, the sun disappearing suddenly or the moon disappearing suddenly can be very, very scary. And therefore, every culture was scared of it and had myths and had stories to explain it. Right? So most cultures had some kind of a demon or an animal eating the sun or the moon during an eclipse, and then you had to force it to go away by beating drums or shouting or doing some rituals and so on. But then long back, around 3,000 years ago, people especially in Mesopotamia noticed that there were some patterns to when the eclipse were caused. The cultures which were very, very scared of eclipses, which were basically the Babylonians or the Chinese, maintained meticulous records of eclipses because they were scared of it, right? And they started noticing some patterns in the sense that they said, okay, if I have an eclipse and another eclipse of some type, then they would repeat after 18 years and so on and so forth, right? So these are called the Saros cycles. And so purely arithmetically, people found out various patterns of repetition in the eclipse when the eclipse occurs, right? And they used this to predict eclipses for a long time. And these were kind of reasonably accurate for a few hundred years, right? But then by the time, third, fourth century, CE rolled over, including, Aryabhatta in India, and of course in China and Babylonia and Egypt and so on, people had started observing the motion of the sun, the moon, the planets a bit more carefully. They started measuring their positions, and they started trying to predict their motions as well, right? This was basically as like a phenomenological model, right? So you fit circles, you fit epicycles and so on. You fit certain parameters, and then you try and predict them, where they would be the next month or next week. And if they differed from where you thought they would be, you then refine your methodology, refine your tables and so on to make it more and more accurate. And in India, of course, we had a wonderful tradition of this, from Aryabhatta to Varamira to Bhaskara to Lalla and so on, right? Up to the Kerala School of Mathematics in the 1800s, which included Nilakanta Somayaji, who came up with what we now know as the Tycho Brahe model a few decades before Tycho Brahe did in Europe, right? But then if you ask any of these astronomers in India, China, Egypt, anywhere, how did this happen? Why are they moving the way they did? We did not know that. Right? That had to wait till we had a dynamical theory which came from Newton. Right? So once Newton came up with his gravitational theory as well as the laws of motion, we could then understand why planets and the sun and the moon and the earth move the way they do. And then you could predict eclipses with much more accuracy, which is what we did. So in some sense, these are three stages of prediction, historically speaking. First, we look at patterns, like 3,000 years ago, and with patterns of eclipse occurrence, you predict where it should occur next. Then you started fitting formulae through the motion of the sun, the moon, the planets, and then use that to predict what happens later. And then after Newton and Halley and so on, we had dynamical theories where you could put in more and more details and perturbations and predict things more and more accurately. So I hope that answers the question. If you look at the feed from Halley, you can now see it's almost maximum eclipse. It's half the sun is covered. The little bit of dark things at the bottom in the Hanley feed is the mountain below which is going to sink very soon. And in Leh, though there are clouds, you can still see the eclipse sun very, very beautifully. So hello everybody. I'd like to welcome another famous astronomer, Professor Siraj Hassan, who's the ex-director of IIA, and he's a very, very well-known solar astronomer from across the world. And he's been a part of the solar astronomy journey of IIA since the very beginning. And I would ask you to just say hello and tell us a little bit about what the kind of things which interest him and excite him about the sun and about this eclipse in particular.
Well, first of all, greetings to everybody. I was just telling the director that I've been to about, I've witnessed at least six, I've been to 6 eclipse expeditions and all 6 have been successful. So that's been really a big bonus. As far as my interest in the sun is concerned, it's been looking at trying to understand what magnetic fields do in the solar atmosphere. And so we've, in most of the eclipse expeditions, we've tried to look for waves to a minute or so. And I think, well, wow. Yeah.
The Hanley sun is setting.
Yeah, that's amazing. Well, I'm not going to go on too long. I'll give it back to Niru.
Maybe I can ask you to say something about one more solar experiment we haven't talked about yet, which is to build a really large solar telescope in India, which you have been a very integral part of, the NLST.
Well, yes, the National Large Solar Telescope Program.
Sorry to interrupt. Neeraj, I'm closing. Yes, it's below the mountain.
Okay, so this is a message from Hanley saying that the sun is set for them. So let's all thank people in Hanley. Crispin, do you want to turn your video on? Yeah. So there's Crispin and his colleagues at Hanley. The sun has set in Hanley now. Can you bring everybody in? We'd like to see all of you and say hello. Everybody in Hanley. Hanley, to remind you all, is a site of our observatory in Ladakh, which is 4,500 meters high. We have now in the camera people from IIA, as well as whom we call the Hanley Dark Sky Reserve ambassadors. These are young people from the nearby villages who are going to become the astrotourism guides for the upcoming Hanley Dark Sky Reserve. And they're very, very happy that they're able to join us here. So, hello everybody. Thanks a lot for your feed from Hanley. We will continue with the Leh feed now, but on behalf of everybody watching us from around the world, we'd like to thank everybody in Hanley for the delightful live stream of the eclipse you've been giving us so far. Now we'll cut back to Siraj Hassan and we'll just let him conclude about the NLST.
Okay, yes. So as I was saying, the project started about more than a decade ago, we were able to identify a superb site on the shores of Pangong Lake in Mira. And the project is now reached a very mature stage. It is now with the Department of Science and Technology, and we are hopeful that soon soon means in about less than a year or so, this project will get the final go-ahead. As far as the team is concerned, they are absolutely ready. All the design and everything has been worked out. The experiments, the scientific team, everything is now in place. And I think it's just waiting for the final go-ahead. Okay, Niruj, back to you. Okay,
Thank you,
thank you, everybody.
Thanks for dropping in. And I think he's on his way upstairs to look at the eclipse
Exactly.
through the eclipse glasses himself. Because in Bangalore, fortunately, the sky actually is clear, which is quite a rare occurrence. So now I'll ask Banya to take a couple more questions from YouTube chat.
So, yes, please put your questions in the YouTube chat box and we can take them. So, one thing I can tell you about the eclipse is in general, how eclipses move on the Earth. Remember, Earth rotates from west to east at a speed of 28 kilometers per hour at the equator. And the moon is also orbiting the Earth from west to east about per minute, I'm sorry, 28 kilometers per minute. And moon is also orbiting Earth west to east about 61 kilometers per minute. Okay, so during eclipse, moon's shadow also moves from east to west with a speed which is difference between these two, that is 68 minus 28, which is 33 kilometers per minute across the Earth's map, right? So that is roughly how this shadow of the moon moves on the surface of the Earth, and that shadow is basically called the track of the eclipse. And in most favorable circumstances, when the total solar eclipse occurs, the track can be up to 267 kilometers wide, and the totality can last as long as 7 minutes. Right? So that happens in a very, very rare circumstances. And the partial eclipse can be seen from a large area on the Earth's surface, as large as 6,400 kilometers wide and so on. Typically the totality, the band of the totality could be 100 to 160 kilometers when there is a total solar eclipse. And the shadow can sweep an area of Earth's surface about 16,000 kilometers, right? So if there is an eclipse, as I said, the shadow moves to different part of the Earth, and from start to end, it could be as long as 16,000 kilometers. And total solar eclipses are rare events, although they occur somewhere on Earth every 18 months on average. It's estimated that they reoccur at a given place only once every 360 to 410 years on an average. So that's like if you are seeing a total solar eclipse at one place, that's only going to be a one lifetime event. And again, I want to reiterate that these eclipses are basically the geometrical effect, and there is nothing supernatural or divine about it. And whatever damage or harm people talk about, that's so. Well, you can see from Leh Ladakh already a very small part of the sun is now seen. Partly it is blocked by moon and partly by the foreground mountains. So this is again a very rare picture that you would see for next couple of minutes or maybe less, because you can see it is shrinking very fast, and in a minute or so the sun would set in Leh. So these are the last couple of seconds that would be visible before the sun sets and this spectacle come to close. Yes, the last part. So we can see that there's only very small portion which is almost now gone now. So that is that concludes the eclipse
From Ladakh.
from the Leh Ladakh. And we are trying to get the feed from Bangalore because sun is yet to set, and we already had some eclipse going on here, right?
Yes, that's true. So the eclipse started in Bangalore only a few minutes ago, and we're trying to get a feed from upstairs, literally. But as you can see, the eclipse is, once the eclipse sets from north, it keeps the shadow keeps traveling downwards and southwards.
Yes.
So while we're getting the Bangalore link, you please continue posting questions, and we will try and answer them while we're waiting. Okay. So how do you visit Leh and Hanley is a question. You'll have to write to us, go on our website, and you can fill up a form for that. Why should we not eat during the eclipse? You can. Shyam's asking, can I watch the eclipse with bare eyes? Please do not do so. It's not safe for your eyes to look at the sun directly. You have to use eclipse glasses or any projection method.
So there is a question on gravitational lensing during eclipse. So remember Einstein's general theory of relativity, which predicts that if there is a heavy massive object in the foreground of a star, then that object is going to bend the starlight. Now that was the theory, and in order to prove that, to give experimental proof for that theory, Arthur Eddington in 1919 eclipse expedition planned an experiment to test the theory. So that happened to be the total solar eclipse day in 1919, and when the total solar eclipse happened, they took several images of the sky and with the background stars. And when you take the same images of the same part of the sky 6 months later, you would see that position of the stars in these two images was different. So there was a slight shift in the position of the stars, and that shift was attributed to the gravitational bending which the sun caused to the background star, or the light coming from the background stars. So this is how the lensing happens when you have a massive object in the foreground and the light is coming from a source which is in the background. It's a myth. So I'm also looking at the questions, and I would respond if there is any question. So there is a question whether Earth is the only planet which can experience the solar eclipse. That's not quite correct. Remember, eclipse is happening when something is coming in between the Earth and the Sun. Now that can be true for any planet. So if there is some other object which comes in between the other planet and the Sun, that would cause the eclipse at that planet, right? So some of the moons of Jupiter as well as Saturn and maybe also of the Mars can have the similar configurations which may cause the eclipse of or solar eclipse for those planets. So it's not the phenomena which is only observed on Earth, but it could be widely observed on outer planets which are outside the orbit of Earth. Okay. Yeah, if you have any more questions, you please feel free to post it on the chat box in YouTube. While we are trying to get you feed from Bangalore, the eclipse has already started here. Sun has not set. Our both feeds that were really very successful from IIA Leh as well as Hanley, we have seen the spectacular eclipse happening there. And right now the sun has already set. So the feed from those two places has stopped. And we will try to have it from here from Bangalore in a short while if we are able to do that. What happens if Earth stood motionless and Sun and Moon rotate about it? No, that's a hypothetical question. Sun is the massive body, and if you look at any other objects in our universe, it's always the lighter bodies which go around the massive bodies. And by the way, nothing can stand still in the universe or in the space. They are always moving. Even the sun and our solar system is going around the galaxy. So it's also, even though we say sun is at the center of solar system, but it's not stationary. In absolute space, it is not stationary. It's still going around the Milky Way. So, some more question. The length of the solar eclipse. The world record. So, as I said already, under West circumstances, the total solar eclipse could last as long as 7 minutes, 6.5 to 7 minutes, and that's also roughly the record. There's a question that Saturn has 83 moons, and can we see 83 eclipses on the Saturn? So remember, eclipses can vary depending on what is the size of the moon and how far it is from the planet, right? So if the moon is really small and it is far away, then you might see it transiting in front of the sun, but not really causing any the shadow on the planet. So again, the occurrence of the eclipse would also depend on in what plane these planets are revolving, or the moon are revolving around the planets compared to the orbit of the planet around the sun, right? And everything is not in same plane. The moon's orbit around the planets can have a tilt with respect to the orbit of the planet with respect of the planet around the sun.
Yeah, so there are a few questions which are on the same topic, so I'll just club them together. While we're so we're getting a feed from the terrace of our institution in Bangalore. So please stay back. You can see now. We can see it. Thanks, Prasanna, for getting that done. In Bangalore, the eclipse started only 10 minutes ago, and the maximum coverage of the sun in Bangalore would only be around 11%. And somebody's asked why is it seen in Bangalore much after Ladakh, and that's a good question because as the moon and the earth go around the sun, the shadow of the moon travels across the earth's surface and it's traveling in the direction from north to south, right? So it started in Russia first, then Kazakhstan and Central Asia, and then it crossed Ladakh, and then it's now crossing Bangalore and South India, which is why you're seeing a time gradient in the way the eclipse is traveling. And in some of the eclipses, you would see that the direction of the shadow of the moon on the earth surface will be different, and therefore the order in which you would see the eclipse from various parts of the globe would also be different. There was a question about Saturn. Did we talk about this amazing coincidence we have of this 400, the coincidence of 400?
Maybe you can tell a little bit about that.
Okay.
Yes.
So, right, people ask why we have a total solar eclipse occurring every now and then on the Earth, right? Now the question is, the moon covers the sun's disk exactly during a total solar eclipse, and you can ask why, right? It ends up being a very interesting coincidence that the moon is able to cover the sun's disk exactly now. The reason is because the sun is around 400 times as big as the moon, right? But the sun is not only 400 times bigger than the moon, it's also 400 times farther than the moon is from us, right? Because of that, the sun and the moon end up having the same angular size in the sky, which is why the moon can exactly hide the sun now. Now, this is merely a coincidence, and you can ask, this is a really strange coincidence to happen, is it natural and so on? It is, because the moon is moving away from the earth slowly, right? And therefore the moon was much closer to us before. in which case you would have covered the sun much easier. In principle, maybe, but then the Earth's size is so small compared to the sun's disk from Mars, like Banyal just said, that you would not be able to see it visually that easily. But then Ravindra Banyal here is also an expert on what we call extrasolar planets, right? Which are planets which we have discovered now to revolve around distant stars, nearby stars. And when you say and when you say eclipses, there is a very interesting and important connection between eclipses and discovering planets around other stars. So maybe you want to say something about that?
Yes. So as you see, we are watching the eclipse when moon is coming between the sun and the earth. Now, when we extend this idea to the stars outside our solar system, and of course, all those stars have planets around them, and now we know for sure that each star on an average has one or more than one planet. Now, as an observer, when we look at these stars, some of the stars and planets will have a right configuration close to the edge that as an observer, you will observe that a planet would cross the disk of the star. Well, you don't resolve planet and stars because they are so far away, the telescope cannot resolve. But by virtue of the fact that the planet passes in front of the stars, it would block certain light of the stars. And now we have instruments, photometers, which are sensitive enough to record that reduction in the intensity. And this is how one of the methods to detect exoplanet works, the transit method. Transit method is nothing but the eclipse caused by the planets around the other stars, which then is the reduction in intensity is recorded by the instrument that are on Earth or space-based instruments. And that's how we usually confirm or validate the presence of planet around other stars. There are other methods also to detect planet around other stars, but the transit method has been the most where almost more than 70% of the total planet as of today are detected by transit method. Remember, today the confirmed discoveries are close to 5,200 and more than 6,000, 3,500 are detected by transit methods. And
Thank you, Banyal. Now, Banyal has been sitting here with us since 4 o'clock, explaining the eclipse to all of us. But I think it's time he went upstairs to see the eclipse for himself. So I'm going to relieve Banyal now. Quickly run out, see the eclipse yourself, have fun, come back.
Yes.
In the meantime, I'm going to ask Ramya and Aratrika to join us. The couple of questions which I think you would like to answer. One is that if you compare the age of the sun to that of the human age, what is the current age of the sun and how long does it take to become a white giant? I mean, I think they mean red giant, right? So basically, the sun's evolution. How old is the sun? What will happen to it? Piyali, Ramya, anybody wants to take that question?
So yeah, I will answer part of this question. So